the moment you've all been waiting for. I'm going to teach you how to solve exponential equations. To solve any equations, you guys know by now that you have to use inverses. So it makes sense that when x is an exponent, or in other words, you have an exponential equation, you need to use logs to solve it. Likewise, when you have a logarithmic equation, you're going to need to use exponents to solve it. Today, though, we are just going to focus on solving exponential equations using logs. We'll get to logarithmic equations using exponents tomorrow. Let's try some. The first method I'm going to teach you is solving by equating exponents, and that's for when you have like bases. How do you know when you have like bases? You need to see what number is being raised up to the exponent. In this case, we have 2 to the 2x and 2 to the 3 minus x. Now, you guys know that 2 to the 9th power is equal to 2 to only 1 power. Not the 7th, not the 8th, not the 10th. It's got to be the 9th. That's the only way that those two quantities can be equal. So using that logic, 2 to whatever exponent this is must be equal to 2 to whatever this exponent is. And that's only going to happen if the two exponents are the same. That's why we can set their exponents, 2x and 3 minus x, equal to each other. Solving for x, we see that 3x equals 3, so x equals 1. In this next problem, we're going to take the same approach. The only problem is that the bases, 9 and 27, aren't identical. You should realize, though, that 9 and 27 have a lot in common. They are both powers of 3. We can express 9 as 3 to the 2nd power. And we can replace 27 with 3 to the 3rd power. If you can get them to be like bases, then you're in the scenario from the first problem. You can just equate their exponents. Since those 3's are the exact same thing, we know that their exponents, 2 times 3x, has to be equal to 3 times x minus 1. Before we solve, we should distribute. And now we can solve for x. You should have arrived at x equals negative 1.
Parents are lazy nowadays. They always say kids are lazy, but parents are lazy too. 7, 8, Lunchables. How much time does it take to make lunch? Huh? How much time? Is what you give me? I love Lunchables, by the way. That's beside the point. Make me a real sandwich. Exhibit B. Instant oatmeal. Are you serious? Is it that hard to make oatmeal? Lazy. Lazy, lazy, lazy.
In this exponential equation, if you look at these numbers, you see that 7 and 15 couldn't be made into the same base. So we need another strategy. If you locate the x, you see that the x is up in the exponent. You ask yourself, how do I get an x out of an exponent? The answer is to do the inverse of exponents, which is log. Now, what you do to one side in an equation, you must do to the other. So we're going to take the log of both sides. But not just any log. We need to take the log base 7 of each side. That's because x is on the base of 7. The log base 7 of 7 is 1. Those are inverses. They cancel. So on the left-hand side, we're left with x equals the log base 7 of 15. If a question asks for an exact value, this is the exact value you should give. But if a question asks you to round to, let's say, the hundredths place, you can calculate the log base 7 of 15. To the nearest hundredth, x is about 1.39. If we're trying to solve e to the x equals 20 for x, again, we can locate our variable x. We see that it's in the exponent. If you ask yourself, how do I free a variable from an exponent, you need to use the inverse and take the log. Now, you're not going to use log base 7 this time. You need to use log base e, or ln, of each side. The ln of e to the x is just x. And the ln of 20 we can calculate. If we take the ln of 20 and round it to the nearest thousandths place, we see that x is about 2.996.
I'm going to tell you about the time my dad was really lazy and I got him back. Revenge is a dish. Best served cold. Ooh.
Isaiah D'Angelo Fredericks.
They said my full name. When parents say your full name, you better hurry up. Oh, yes! That money, he's going to ask me to get something.
Can you hand me the remote?
Where is it? Right here. Are you serious? It was right there. Lazy, 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 I say.
Thank you. Zay!
Yes?
Can you turn the TV off?
Yes?
Thank you.
You're welcome.
Zay!
Yes?
Come here. Can you turn the TV back on?
Okay.
Thank you.
You're welcome.
Can you take my socks off?
Yes. Ew. This is so nasty. I can't even smell it. Look at those crusty feet. One word, pedicure.
You guys know that when we solve equations, you have to isolate the weird guy first. Nothing changes with these exponential equations. If you look at 40 equals 5 times 3 to the 2x, you see that 3 to the 2x is definitely the weird guy. It's that 5 that has to go. 5 is being multiplied by 3 to the 2x, so to get rid of it, we can divide. We see that 8 equals 3 to the 2x. Now, how are we going to get 2x out of the exponent? If you said take the log base 3 of both sides, you were right. If we take the log base 3 of 3 to the 2x, we see that we're just left with 2x. On the left-hand side, we are left with the log base 3 of 8. The log base 3 of 8 is not an integer, but if we divide by 2, we have an exact value for x. That is the log base 3 of 8 over 2. If you want to calculate that, though, and round, you can do that as well. We can calculate the log base 3 of 8 and divide that by 2. If we round to 2 decimal places, we see that x is about 0.95. In this last problem, we are going to use the same method, and we are going to isolate the weird guy first. Hopefully you agree that e to the 0.25x is the weird guy. In order to isolate him, we must first add 2 to both sides and divide by 9. Now, 0.25x is up in the exponent. To get a variable out of an exponent, we must use logs. For this one, we need to take the ln of each side, because that 0.25x is the power on base e. The ln of e cancels. We're left with 0.25x equals the ln of 3. In order to get x alone, we just divide by 0.25. And we're left with x equals the ln of 3 over 0.25. Again, if you're asked to round, you should calculate this and round. We can see that the ln of 3 divided by 0.25 to 3 decimal places is about 4.394.
Can you give me something to drink?
Yes. After I touched those slave feet, I had it up to here. Revenge. Burp on it, Joe. Ding, ding. Here's your drink, Daddy.
Thank you. You're such a good son. I love you. This tastes a little funny.
I'm official Zay, and that was evil.